So when I tell you we're going to do applied right triangles, it just means we're doing word problems. Because applied means how it works out in real life. I don't know if Lauren got them. Did you get it, Lauren? You don't want any. Okay. Just keep passing them, Brenda. Okay, I have 4 examples for us to work through together. Your assignment tonight is almost entirely word problems. So I'm going to give you some time to start working on that in class so that you can, I know some of you have Broadway today, some of you have, practice after school, soccer, basketball, track, tennis. Have you guys started tennis, Michael, already? Kind of. You're not going. Okay. Well, so I know a lot of you have a busy full day. So I'm going to do 4 examples with you and then give you some time to work. Okay? All right. Here's our first example. Uh-huh. Okay. Snoo is trapped in a burning building. If you know anything about Miss Snooing, you know that while this might, be a nightmare for some people, this is would be her dream come true, to be trapped in a burning building, because it would mean that she would get rescued by a firefighter. All right, she just has a thing for firefighters. So we're going to put Snoo in a burning building, and we'll have someone come to rescue her. Okay, she goes to a window, and the window is 105 feet off the ground. Or we could just say high, that would be easier. All right, 105 feet high. The fireman arrives, and he has a ladder, and so a fireman leans his 140-foot ladder up against the building to rescue her. And the question that has to do with trigonometry is, what angle of elevation did the fireman use to lean his ladder so he could reach her? So what elevation angle was used? Okay, because if he uses the wrong elevation angle, he'll either be too short and his ladder won't reach her, or he'll be too high and his ladder would be above where she is. So you got to have the right angle of elevation to get his ladder to reach her exactly. All right, so let's take a look at this. Here is the building burning. It's on fire. Okay, we've got smoke coming out. We've got Snoo leaning out the window saying, "Save me." Okay. All right, so there she is. We know that she is 105 feet high. And we know that, we can picture this as a right triangle. The ladder that the fireman is using to reach her is 140 feet. And so then the question is, what's the angle of elevation? Well, we know where the right angle is. Okay, the right angle is against the building. The angle of elevation would be right there on the ground leading up. So this isn't too bad of a problem to set up and solve. We just have to decide what trig would be best for solving this. So what do you think? Sine. Okay, yeah, we're going to use sine. And so we use sine, and after sine we write theta, because that's the angle of elevation that we're using. And that's going to equal opposite, which is 105, over hypotenuse, which is 140. Now I'm not going to cross multiply this problem because what I want to get by itself is the theta. And so if I need theta alone, I need to get rid of sine. And last night's lesson that you watched the video on and did some practice on, what's the only way to get rid of sine? To use sine inverse. So we're going to use sine inverse around both sides of the problem. So sine inverse on the sine theta side. And it's always a good idea to put parentheses around it when you use that. And then we'll use sine inverse on the 105 side, and we'll put parentheses around that. So on the theta side, the sine inverse cancels out the sine, leaving us theta by itself, which is what we want. And then on the flip side, we're going to just make sure, and we're in degree mode, and type in, go ahead and use your calculators, you've got them out, sine inverse of 105 over 140, and you can tell me what that angle should be. Okay, who's got that? Yeah, Ryan. Okay, and that's the angle of elevation at which she will be rescued. So the purpose of tonight's homework is to do that inverse. You're going to need an inverse for every single question, but you're doing it in a word problem where you start with SOHCAHTOA and then do an inverse to figure it out. Okay, let's try another one. That was example 1. We'll get on to example 2. Okay. All right, a person on a bridge. Maybe it's the Golden Gate Bridge or something in San Francisco. That's a pretty big bridge, not just a little small freeway overpass or something, but a pretty big bridge. $980 feet high. This is a significant bridge. All right, so I'm thinking like Golden Gate Bridge in San Francisco, or the Brooklyn Bridge in New York, or the London Bridge in London, something big. Okay, and they see a car below, and the car is 450 feet from the base of the bridge. Or we can say from the bridge's base, so from the bottom. Find the angle of depression. All right. So again, we're just going to try and picture this in terms of a right triangle. So let's see if I can draw that. Okay, we've got the Golden Gate Bridge here. Got a person standing on the Golden Gate Bridge. Okay, we know that this person, is 980 feet high. They see a car below. So here's our little car. 450 feet from the base. Some of you misunderstood in your quiz about the ship and a cliff, and you didn't understand along the water and the base where the ship was, and you put it like in the diagonal part of the air. That's not what we're going for here. This is from the base of the bridge. And so my triangle is my person looking there. It's going to be formed like that. So we know where the right angle is. And we were asked about the angle of depression. So the angle of depression is outside of the right triangle, and the angle of depression is right underneath the person, but it's not actually in the triangle. But we have a theorem about the angle of depression that we learned last week, and the theorem tells us that the angle of depression is equal to what other angle? Angle of elevation. So it's going to be the same as that one. So then that's the position of the angle inside the triangle. And so then I'm going to look to set that up And that looks like what SOHCAHTOA would be a great relationship for that one. Tan. All right, so we'll set up tan. Tan of the angle of elevation will be the opposite over the adjacent. So 980 over 450. And I'm not cross multiplying here either, but I'm trying to get theta by itself. And so I'll use tan inverse around the parentheses of tan theta. And on the other side, I'll use tan inverse around the parentheses of 980 over 450. And so on the inverse tangent side, it crosses out. I'm left with theta by itself. And then making sure I just type in tan inverse and use the calculator to find that. Who's got that one? 65.23. Yep, I agree. All right. And that is the angle of elevation, which is equal to the angle of depression. So I've answered the question by finding the angle of elevation. I've answered the question for the angle of depression also. Okay, any questions so far? We're halfway done. Okay, great. All right, example 3. A swimming pool. The swimming pool is 60 feet long. The shallow end of the swimming pool is 4 feet deep, while the deep end is 10 feet. What is the slope? And the word slope also means depression angle of the bottom of the pool, because it's definitely slanted to go from the shallow end to the deep end. All right, so let's see if we can picture that. We've got our swimming pool, 60 feet long. All right, so I'll put 60 feet across of water. And we know that that is 60. The pool has a shallow end that is 4. It has a deep end that is 10. Bottom of the pool is slanted, and we're trying to figure out that slope. Now that shape is what we call a trapezoid. But within that, you should see a right triangle. Okay, where is the right triangle? Or how can you make a right triangle into that? Okay, so cut off the part from the 4. In other words, go straight across. Yeah. All right, so I'm going to split this right here. So basically, I'm going to split off a rectangle that's all water, and I'm going to put my right triangle in there. All right, now 10 is from top to bottom. How much is the triangle part that I've created now? It's just 6. All right, so we have a side of 6. We have a side of 60. That's the same as the width all the way across. And then we want the slope, or the angle of depression, from the pool's bottom. Okay, the angle of depression is right there, which is actually inside of my triangle, so I'm all set up already. And I've got that perfectly worked out. So looking at the right triangle only, I just have to pick the SOHCAHTOA that's going to work best. And what do you think for this one? Tan again. Yeah. All right, so tan set up as of theta would be opposite is 6, and 60 is the adjacent. So again, we're not cross multiplying here. We're just trying to get theta by itself. So we'll use inverse tangent with parentheses around tangent, theta. And then on the other side, we'll use inverse tangent with parentheses around 6/60. Cross out the tangent and the inverse tangent. So theta then would be the inverse tangent of whatever 6/60 is. And I get 5.711. Yeah? Okay. Okay, so the last one's going to be a boat. How many of you have been out to the Seal Beach Pier? Anybody been out there? What used to be out there?
Rubies.
Okay, rubies. It burned. It's no longer there. But what do they still use the pier for? Do you know?
Fishing.
Okay. Yeah, off the coast, if you look off the end of Ruby's Pier, you'll see an oil derrick out of there, and there's a boat that goes back and forth, ferrying those boat workers, those oil rig workers, back and forth from the end of the pier out to their rig. So I want you to keep that picture, if you can picture that in your mind, and we're going to do a little trig with that. So we're going to talk about a boat. Ferries workers to and from a dock to an oil rig. The course is 2 miles west. That's out to sea. Okay, 2 miles west and half a mile south. What bearing, and another word for bearing in the ship world is heading, that's also the same thing, does the boat use? Because the boat doesn't really want to sail straight west and then turn a corner and sail straight south. The boat would rather go on the diagonal, the hypotenuse. So we need to know what the bearing or the heading is that's used by the boat. So let's see if we can picture that. We're going to look at this from like an aerial view. So we'll be like in an airplane looking down on it. Okay, so you've got, here comes the end of the pier, and then here's the oil rig out here. So we know that the charted course from the dock out to the rig is 2 miles. Okay, I need to draw mine. Hang on. Let's draw this the right way. Seal Beach. Okay, the pier is going west. All right, here's the coast. All right, here's the pier. All right. Out in the water is the rig. There, that's better. Now it actually looks like Seal Beach. Okay, we want to go 2 miles west. So that'd be like that. 2 miles. And we want to go a half a mile south. And then we got to figure out the angle that the boat would actually use when it sails directly there. The angle we're going to put in, the theta, is right in here. So just like our other questions, we're going to set this up with tan. So this is tan of the corner theta equals opposite, which is half, over adjacent, which is 2. We'll use inverse tangent on both sides. So tan inverse with parentheses around tan theta. Tan inverse with parentheses around the 1/2 and the 2. So theta, I'm doing my tan inverse right. What'd you guys get? I think I got something. I just want to check. What did you guys do? Yeah, okay, good. All right, I got 14.036 degrees. Okay, that does not finish the question. All right, let's look at this. This is 14.036 degrees. The question is, what is the bearing? That is not the answer to that. Yeah. You know how to figure it out?
Yeah.
Okay, tell me.
So once you subtract that by 90, so then you get a bearing for that quadrant, and then you add 2 more 90s to that with the whole bearing on the side.
That is definitely one way to do it. That would be perfect. Okay, so he's talking about figuring out how much the bearing is. Okay, let's, one way I would think about it, that dotted line, what bearing is it closest to, like on a perfect north, south, east, west? What would you say if it's 14 degrees? What's it closest to? Okay, not just north, south, east, west. Don't use any of the sideways ones. What would you say that would be closest to? If only 14 degrees. I'd say it's closest to west. Okay, it's only 14 degrees away from being west. So it's pretty close to being west. I didn't maybe draw that perfectly because 14 degrees is pretty small. How much is, what's the bearing for west? You guys remember? It's perfectly 270, right? And so is this more or less than that? Less. Okay, so you do 270 and you take away the 14.036 degrees. All right, so when we actually want to answer the question, you got to do one step more. I would say bearing is 270, which is west, minus the 14.036. And that will give you the bearing heading that the ship should use. So 270 minus 14.036. That gives me a bearing heading of 255, 964. All right, what Ben was saying is he was saying add up a bunch of 90s, right? And that would work too. So I think Ben is picturing in his mind kind of like a compass like this, and he's saying 19.4036. But this, you were thinking, figure out that that's 75,964 in this underneath it. Like there's 14 on top, but there's 75 underneath. And then you were saying, well, there's 90 over here in a right angle, and there's 90 over here in a right angle. And so add up 90 and 75,964, and then you get the same answer. So either you can do it by adding things up, or you can start with 270 and subtract, and you get the same answer either way. And so that's the bearing. My experience is on questions like this, most people get the 14.036 degree correct, and then they like stop, and they don't actually answer the question that is, what is the bearing? So there is, for bearing, there's always a step further. It's never just the answer that you get. You always got to go a little further to figure out, to say what the direction would be. Okay, so that gives you like a half an hour to a little bit less to crank out your homework. Some of you may finish. Some of you may not quite finish, but at least it will be less time that you'll have to spend at home tonight. Yeah, Michael?